Hello and welcome to your very first AP Psych screencast. This is Walker Asserson. I'll be talking to you today about Unit 1, Scientific Foundations of Psychology. Um, with psychology, there's lots of things we know about why people do what they do and how they do it and their emotions and their stress and their thoughts. But the question we're going to start with in Unit 1 is how do psychologists know what they know? And the answer is they do a lot of scientific research where they're coming up with hypotheses and theories and they're testing them out. And there's about 7 different ways that psychologists do research. And so that's what we're going to be looking at. There's going to be several videos to cover this unit, and this tells you what's in each video. So today's screencast is going to be about experiments in psychology. So let's get started. First of all, we're going to learn tons of actual experiments that have been conducted that are really famous in psychology, that have revealed all kinds of fascinating aspects of humanity. But we need to know, like, how do they do the research? So in this screencast, we'll recap the scientific method. We'll talk about different variables, groups, randomizing, a couple of things called standardized procedures and confounding variables, and we'll also talk about bias and how researchers prevent bias. So how do they ask and answer questions? Scientists, psychologists all use the scientific method, the same thing you learned probably when you were in 5th grade. You start with the theory, you have a hypothesis, you test it, you get your results, you publish your results. Psychologists have a bunch of magazines that they publish, that they read, that have all these experiments and all this research data in them. So how does the process look in real life? You would start with a theory. For example, low self-esteem feeds depression. That sends you to a hypothesis. For example, people with low self-esteem will score higher on a depression scale. That leads to research and observations. For example, you would administer tests of self-esteem and a test of depression, see if low score on one predicts a high score on the other, and that data would either confirm or reject your theory. So that's how psychologists do their research. With experimentation, psychologists are discovering cause and effect. Does this one thing cause another thing? Does this variable have a certain effect? Does it cause, and is there an effect? So experiments are the only type of research that isolate causes and their effects. I said there were 7 types of research we're going to look at. Only experiments deal with cause and effect. So in an experiment, the researcher is going to manipulate one factor that they're interested in. All the other factors will be kept under control. And I have an example of that I will share with you. But let's repeat that. One thing is manipulated. Some people get it in the research study. Some people don't get that one thing. And then you measure the results, and everything else is kept under the same circumstances. So the thing that you are manipulating is called the independent variable. So it is manipulated. Some people in the research study will get the independent variable. Some people will not. And you're checking the effect of the independent variable. For example, if you wanted to examine the effects of breastfeeding on the intelligence of the baby, breastfeeding would be the independent variable. Your study would be that half of your women are breastfeeding their babies, half of the women are bottle feeding their babies. 8 years later, you measure the intelligence of the babies. So you're studying how they're fed, and does that affect their intelligence later on? The dependent variable is the factor that is measured, so it can change in response to the independent variable. For example, in the study on breastfeeding, when you're measuring the intelligence, That's the dependent variable. So you have two groups of people in a research study. You have the control group and the experimental group. The control group is the group of research subjects that does not get the independent variable. Since they don't receive a treatment, they're serving as a baseline for any changes that do happen to the other group, which is called the experimental group. So all the other variables that could be present in research subjects are the same in the control group and the experimental group. The only thing that's different is, in our case, what type of milk or how the babies get their milk. So that's the only thing. So age would be the same. Um, Socioeconomic status would be the same. Education of the parents would be the same. So you'd keep all these variables the same. The only thing you would change would be how they got their milk. And the control group is the group that does not get the independent variable. The experimental group is the group who receives the independent variable. They're the ones being manipulated. They are receiving the treatment that is being tested. The only difference between them and the control group is the one single independent variable. You try to keep everything else the same. Okay, so when you're setting up these control groups, experimental groups, when you're selecting your participants, you have to do some things randomly. You have to have random selection. Which babies will be in the research study? You have to select those babies by chance. Once you select who's going to be in the study, you have to assign them to the experimental and control groups. Again, you have to do it randomly. You have to do it by chance. You do this because if there's any pre-existing conditions, if there's any pre-existing differences between the experimental group and the control group, you want to make sure that those are neutralized by randomly assigning them. So that's a way you make sure that any differences that exist in the babies don't interfere with your experiment. So that's how you do that, random assignment. So here's a summary of the steps of experimentation. You have your two conditions, experimental control group. You have your dependent variable, the breast milk or the formula. Formula is the bottle milk. And then you have your dependent variable, intelligence score at age 8. So there can be bias in research. There can be experimenter bias. If you're doing this study on breast milk and formula, you might be super excited. You might believe that breast milk affects intelligence. So you want to keep that bias under control. And one way you can do that is called a double-blind procedure. That's when the people carrying out the research and the ones participating do not know if they're in the experimental group or the control group. So you don't always do this, but some research this works really nicely for. It works especially well when you're evaluating drug therapies, like let's say there's a new drug to treat depression. So researchers would use something called a placebo. A placebo is a harmless pill. You would give it to people. They would think it's the antidepressant medication, but they wouldn't know maybe it's a placebo. So the placebo is a pill that would look just like the real pill, but it wouldn't actually do anything. Sometimes placebos, if people think they're getting a medicine, they might feel better just because they think they're getting a medicine. So the placebo neutralizes that. So that's a way to reduce bias also. Okay, a few more concepts here before we wrap up research, before we wrap up experiments. There's something called replication. So psychologists use replication to find out if the findings of a study can be verified. So we found out breast milk had this really important effect, but is that just one fluke experiment, or is that going to be true if other people try the same research? So replication means that other psychologists try to do the exact same study following the exact same standardized procedures. If the results are replicated, then you know the research is good. So I just used the phrase standardized procedure. What does that mean? when you do a study, if you have 30 babies, you have to keep everything in the study the same for all participants so that the research is fair. So all babies get breastfeeding the same, all babies get the same formula. As much as possible is kept the same. So in other research, it might be maybe you're reading directions to the participants, so you read the exact same script, you use the exact same equipment, you do it at the exact same location. So you have a standardized procedure so that everybody is treated the same when they do the study. So in this little picture down here, good science is when it's done 3 times and you get the same results. Bad science if it's just done once and it's not replicated. Okay, last thing here. Researchers also have to use operational definitions of the factors they're studying in their research. This means they have to specifically define things they're measuring, like happiness or stress or intelligence. So, for instance, happiness is something you might want to measure, but that means a lot of different things to a lot of different people, like in this picture here. So if you were doing a study measuring happiness, you would need to say happiness will be measured using a mood scale of 1 to 10, and those rating above a 7 will be defined as happy. Now that's just an example. You could define happiness however you would define it, but you need to specify in your research. You need to have operational definitions so that other people know what you mean. Okay, last thing here is confounding variables. When you do research, I was saying for the control group and experimental group, there's only one difference, the experimental condition. However, some other variables might sneak in there and they might affect your results. So sometimes variables the research did not think of can interfere with the accuracy of the results of the research. These are called confounding variables. They're extra variables that entered into the research that were not accounted for. They're like the movie Wedding Crashers, people showing up, ruining the wedding. So they are crashing the party. I'll give you an example. Let's say you're doing a study measuring the effects of caffeine on wakefulness. It is possible that the experimental group also had, on average, just by chance, a better night's sleep before the day of the research study. This extra variable would throw off the results. So you want to pre-think about confounding variables and try to account for them before you do your research. Okay, final thing here, strengths and weaknesses of an experiment. A strength is that experiments can determine cause and effect because you're only manipulating the one variable. It's the only type of research that can determine cause and effect. Weakness, you could have researcher bias, you could have confounding variables. Also, your effect might show up in a lab, but it might not transfer to the real world. So there you have it, experiments. If you have any questions, see me in class or send me an email.